Hi, I'm Guo Cheng Guang, secondary one for NS High School. Right now here, we are at our organic chemistry at chapter 1, classification of organic compounds. For this part, although you see that the examples that we're having here are all about like inorganic compounds, but although we start with these inorganic compounds, we're just going to learn the calculation by using these inorganic compounds. And last, we're still going to use organic compounds for these. So, some of these things that we're going to calculate, like for example, the types of energy. Now, the types of energy can be the heat energy. Heat energy can also be called thermal energy. You can have internal energy, or you can find these. Or you can find activation energy. You can find bond energy like between bonds, the type of energy there. Or another type of energy can be the free energy. Well, free energy, there are two more types, and these two types, well, one is Gibbs, the other type is Helmholtz. Okay, so those are just two types of free energy that we may be learning. So then after that, other than types of energy, you can also find different other things, like for example, heat capacity. You want to heat it up until what level and how much heat can take. Heat capacity, specific heat capacity, and you have different conditions for it, like for example, specific heat capacity at, well, constant pressure, maybe, or it can be constant volume, okay? Then you can also have your chemical potential. Or if you're thinking about heat again, then you may need to have enthalpy, entropy, these things. So for these, I'm saying just like some of them that we are going to find. Well, there are actually many other things out there. Well, those are just some. So let's take a look at the example we have in this type. So two electrolysis cells are connected in series to the same source of electricity. So the names right here we're still using for electrolysis, and in electrolysis we can find the mass, the time taken, and the current. Okay, well, electrolysis, as its name states, and trolysis. Well, electro and lysis actually. So electro, it means for electricity. The lysis, whatever you pronounce it, like lysis. For that part, it just means breakdown. So electrolysis, it means breakdown using electricity. Okay, let's go on. So if 10 grams of copper is deposited from copper sulfate in this part it states, it actually means in the first electrolysis cell, what is the mass of silver deposited from silver nitrate in the second electrolysis cell actually? So for these parts, it's about copper and silver. Copper from copper sulfate, silver from silver nitrate. So for this type of question, first of all, what we have to know will be their ionic. So you have chemical equation, right? So you have ionic equation. So for this part, copper in this part is 2 plus. So that means you need, when copper is broken down apart from the copper sulfate, you get 2 plus. So that means you need to add E minus, well, you need 2 of them in order to get Cu. Okay, you need like this. Then after that, how about for silver? Ag. So silver in this part is actually just plus. So you only need 1 electron to get your silver. So these are separately copper metal and silver metal. Alright. So you want to find what is the mass of silver that you get. Well, let's see what we're given. We are given the mass of copper that we've got. Okay. Now we want to find mass of silver. But wait, we only know the mass of copper. How is that possible? Well, let me just tell you. Here is when you need to be really careful. So they are connected in series to the same source of electricity. So basically the same circuit. So this the time taker is definitely the same already. Then after that it says in the first sentence, are connected in series. So series for circuit, if you go back to find like videos about the physics or this electric circuit part, you'll find that when a circuit is connected in series, the current is the same. So time and current, they're all the same now. The only difference is its mass. Alright. So we can have number of moles of copper. So number of moles of copper, this will be, so you're using the copper, the mass of the copper that you get, which given here is 10 over, or you can say it is over the atomic mass unit of copper, or you can just say the atomic mass of copper, which is 64. So then after that here, when you simplify a little bit, you get 5 over 32 for this part. So here is number of moles. Then after that you can find for number of moles of silver. Well, then you may ask, how are you supposed to find this? Let me just show you. Here is when the ionic equations come in help. So here number of moles of copper, when you times 2, is actually the number of electrons used. Alright, so when this times 2 is the number of electrons used, that means it's actually the number of electrons given from the current. Well, it is given from this current. So that actually means, because we are given that it's connected in series, so that means the current is the same. So that means you just need this part times 2, because for these 2 electrons, then you get it 5 over 16 moles. And if you have for this part, it's just 1 electron to 1 silver. So that's how you get number of moles of silver. Well, then in this part for number of moles of silver, since you already got it for number of moles, that means you can already find mass of silver. So this mass of silver, for this part, what you need to do is just 5 over 16, then you times. So mass of silver, mass. So just times the atomic mass unit, well, given for silver. So in this part, if you have learned your periodic table until very well, you can know that this is times 108. So from this part, you can choose to calculate it mentally, or you can also choose to use a calculator to calculate for it. Okay, so right now, I'm just going to use this calculator here. Okay, so it seems like what you get will be 33.75, but just beware that this mass here is also rounded off. So the mass is this part, and in fact it is in grams. So actually this question seems very long. Yep, this question seems very long. But if you understand it, it can just be this short. Or this is just like a very shortcut method. If you want to do it in the long method, then you can find, okay, well, that current method, I'm not going to write it out. It's going to be very, very long. So first of all, you're given mass of copper, right? So mass of copper, you can find number of moles of copper, then you can find number of electrons of copper. Well, is number of moles or number of electrons given to copper, which is the same as number of electrons given to silver. So then you can find number of moles of silver, then back to mass of silver. Or if you want to go all the way, then you can keep on finding until the time taken, well, that is going to take very long. But what you'll realize at last is they'll all cancel out. Alright. Well, how is that possible? Well, it's just because the conditions given, same source of electricity, so that means same time taken or same time given, series in this circuit, so same current. So if you just go and find all those again, then they're just going to simplify again. So then it becomes useless. So the fastest way, you just need number of volts of copper, and you know that how you get number of electrons. Then you can get number of moles of silver. So it is actually just that fastest way. Okay. So from this part, I'm just going to end it here, and I hope that you could understand this so far. So I'm just going to tell you about this again. Right now, here's your electrolysis. Electrolysis, decomposition using electricity. So the important things that we're just going to find will be for mass. We can find it with current, or if you want, you can even find charge or time taken. Okay, so right now for electrolysis, we're just finding for these things. But there's something that you have to know. Like, for example, Avogadro's number. Avogadro's number, definitely you have to know. Or charge of electrons. Yes, you also have to know that. And for these elements here, or these atoms here, you also have to know their mass, or their atomic mass unit. You also have to know those. You also have to know ionic equation. So like after you separate them, what would they become? Then how much electrons would they need to take? Okay. Then after you also have to know like about these compounds. So in this case, we're just using copper sulfate and silver nitrate. Okay, so that's pretty much what we have for this time here. Alright, so I'm just going to end this lesson here. So if you like our videos, don't forget to subscribe to our channel. We'll see you in the next lesson. Thank you for your watching.